Okay, so we need to look at the cables. You need to know the different wires you have in the domestic wiring. So the first cable, the most important cable, is called the live wire. So this is wrapped in a brown sheath, so plastic sheathing around the cable with the copper braid in the middle, so it can be easily identified. The important thing about the live wire is that's the one that has or carries the PD. So that has the voltage, so that's like one end of the battery if you like. And it's that has actually an alternating PD, so the PD changes, and it's that causes the alternating current that you get in a power supply. So the graph would look very similar, but obviously you have PD on the axes against time, and as you can see, it constantly alternates. The live wire basically carries the PD to things in the circuit, so it carries the PD to the sockets for when you plug something in, or to the lights, or whatever it is you're powering. So that's, if you like, the cable that goes to things. The second wire is the neutral wire. So the neutral wire has a blue insulating sheath around it to make it easily identified. Clues in the name, it's the neutral wire, so it is neutral, and that means it has no potential difference. It's always at 0 volts. Its job is it provides the route back, if you like, or the return path. So that's how you get a complete circuit running from the live wire through the appliance onto the neutral and back to therefore complete the circuit to allow current to flow. The third wire, which not all appliances have, is the earth wire, or the earth cable. So this has a sheath that is green and yellow, or yellow with green stripes. And the earth wire is not actually part of the circuit, so you don't need it to make things work. Just the live and the neutral are only the bits of the circuit you actually need. But the earth wire does play a safety role, and if there is current flowing through the earth wire, it's usually a sign that something's gone wrong, and then that causes some other safety element to kick in to help protect the device and the wiring. And the earth wire also has a symbol, which you'll need to know, and some appliances also have this symbol on them. So this is the symbol for an earth wire or earthing, so that's quite important later on. Okay, so circuits in the home, you don't need a lot of detail about this, but a cable terminally is called a 3-core cable. So it's got the live in its brown sheath, the neutral in its blue sheath, and then a bare copper wire in the middle, which is the earth, which you then place a yellow and green earth sheath over when you're wiring it in. So obviously the live and neutral are already covered in insulators, so as long as the live can't get to the earth or neutral, that's fine. So within the home, you have a consumer unit. In old-fashioned terms, that used to be called the fuse box, because it basically does the same job. And coming into there, after it's been to your electricity meter, is a really big cable, which is the mains feed in, which has a big fuse to protect it. We'll talk about fuses later. You've got a big master on-off switch, and then you've got several miniature circuit breakers, sometimes known as MCBs. They sort of do the same job as the fuses. Miniature circuit breakers. Each one of those is protecting a different circuit around the house. So this one, for example, might be a 32 amp miniature circuit breaker, and that might be running a set of sockets. So the live cable comes in, goes through the on-off switch. When that's turned off, it disconnects the live cable, meaning that there's no PD getting to anything. When that's turned on, this cable is now live, which means PD is getting to all these circuits. When this is switched on, it means PD is now able to go along the live wire to each of these sockets. So the live pin in each of these sockets is live when you plug something in. You plug an appliance in, the live cable or live flex within the appliance lead connects to the live wire that's in the socket, which means potential difference now gets to the appliance. So here's, for example, the TV. So current can now flow through the TV and connect back to the neutral. So the PD means you've got a route to the appliance, and then current can flow to the appliance, go through the circuits inside the appliance, and then back down the neutral. So the neutral is still neutral, it's still at 0 volts, but it's carrying the return current. And the neutral wire also connects back via the socket route back to the consumer unit. All the neutrals connect together and then connect back down the main cable. That, in the old-fashioned system, used to go to ground, or it goes back to the substation to return to the national grid to complete the circuit there. So each separate circuit, so this might be the lighting circuit, but would have a cable that took the live to every single individual light fitting, and then the neutral would return back to here to complete the circuit. And you might have one for electric oven or shower, they have a separate circuit. These are all separate circuits, and the live wire goes from them to whatever the circuit's running. So the live wire takes the PD to those appliances, and the neutral wire gives the return route. Remember, at all times, there is not a PD on the neutral, so the neutral remains at 0 volts all the time. But there is a PD on here, and that is, in the UK, 230 volts, and it's an alternating PD, so it keeps changing. And then when something's plugged in and connected, the PD alternating on the live wire connects through the circuits of the system to the neutral, so that you get a current flowing through the live wire, through the appliance, and back along the neutral wire. So you need a basic idea of the safety systems that are built in to the domestic supply. So the first thing you've got are the MCBs, or the miniature circuit breakers. Remember, each one of those protects a different set of wires, a different circuit around the house. And they have one job, and their job is if too much current flows, it's all about the current, so if too much current flows for their circuit, so the sockets can have thicker wires so they can deal with more current, lighting has less current so it has thinner wires, but obviously you don't want too much current to flow through. So if too much current flows, they trip off or they disconnect, they switch off, and what that does, it stops or disconnects the live wire from the main supply actually getting to the circuit at all. So the live wire in the circuit is no longer live, which means that it's no danger of it then completing a circuit with anything else and causing electricity to flow. Fuses, so these are in the plugs that you plug in when you plug in an appliance. So each appliance has what's called the flex, that's the cable that runs from the appliance to the plug, and they work in a very similar way to miniature circuit breakers. So if for some reason something goes wrong and the appliance tries to draw too much current, so again it's all about too much current, so if too much current tries to flow through that fuse down the wire into the appliance, the fuse breaks, or as they call say a fuse blows, but in effect it snaps. That has the effect of disconnecting the live wire that's going from the socket to the appliance. So the socket's still live, but the plug has disconnected in effect from the socket from the appliance. So then there's no chance of any PD getting to the appliance, so there's no chance of it creating a circuit or anything going wrong or any additional current flowing. Then the earth wire, so this is only there in case something goes wrong within the appliance. So the earth wire has a low resistance, so an easy route to earth, to ground. So if something goes wrong inside the appliance, like a wire comes loose or something, and suddenly there's a live wire touching the inside or somewhere it shouldn't, this causes a surge in current to flow. That surge in current, because we've got an easy route to earth now, means too much current flows, so it blows the fuse. When the fuse blows, that disconnects the faulty appliance, and therefore the appliance is no longer connected, so therefore it's been switched off, so now it's safe and obviously not working. The alternative is someone goes to pick up or touch the appliance, they become the route to earth. You still get the surge in current and it will still blow the fuse, but of course that surge in current is going through the person, which isn't good, and they get electrocuted.